So, let us briefly look into the concept of conditional probability. One of the very critical topics in probability theory is the conditional probability. So, if E1 and E2 occur in succession, then the conditional probability of E2, given that E1 has already occurred, is given by probability of E1 intersection E2 divided by probability of E1. This notation indicates that whenever the occurrence of E1 influences the occurrence of E2, then this is how you compute the probability of E2. But sometimes E1 does not influence E2. When E1 does not influence E2, we write probability of E2 given E1 is equal to probability of E2 itself. That means E1 does not influence E2. Suppose we denote this with equation number 1. Then we can use this result in equation 1. So, 1 can be written as, assuming E1 has no influence on E2, this gets reduced to probability of E2 is equal to probability of E1 intersection E2 divided by probability of E1. So, if you cross multiply, you get an interesting result. Probability of E1 intersection E2 is equal to probability of E1 into probability of E2. So, let us call this 2. So, this is to be treated as the condition for independent events. This can be remembered as a formula when the events are not independent. So, one has to carefully observe and then look into. If the information is that E1 and E2 are independent, then you can invoke this formula. Otherwise, you invoke the conditional probability rule. So, let us look into some illustrations, but the Bayes theorem is something which uses the conditional probability very effectively, but we can see that in problem solving. The only thing about Bayes theorem is it can also be solved without a formula, but by drawing a tree diagram also. So, we will see according to the context depending upon the easiness or difficulty of the given problem.